Hi grade 12s and welcome. It's Mr. Mustafa here. In this video we're going to solve the 2023 Mathematics Paper 2 IEB, the final examination. So let's go straight into question 1. Right, so question 1 is based on statistics. The percentage results obtained by 26 learners in a mathematics test is displayed. So we have 26 learners is displayed in the box and whisker plot below. So remember, the box and whisker plot is given, so we know this is the minimum value, this is Q1, Q2 is also the median, Q3, and we have the max value, right? So what we can do here is, let's see what information is given. The range of the data is 80. So what is range? Maximum minus minimum, right? So maximum is 95 minus the minimum is 80. So we can say 95 minus A is equal to 80. Determine the value of A. A is a minimum. So we know the range is 80. IQR is 30. So first question, they're asking us for the value of A. So max minus min is equal to 80. So therefore, we can take the A over and the 80 over. 95 minus 80 is 15. So we know the value of A is 15. Next, we want to find the value of B. The value of B is IQR. IQR is Q3 minus Q1. Q3 is B and Q1 is 40, and that's equal to IQR of 30, and the value of B is 70. So remember, max minus min is equal to the range, right? And remember here, IQR is equal to Q3 minus Q1. So we know the value of B is 70. Right. Sometimes just interpreting the box and whisker plot, if we're looking at it, we can see the distance from the minimum to Q2 is bigger on this side, so the data is skewed to the left. What else can you see from the box and whisker plot? They can ask you for the probability of learners that scored more than 40% in the math test. So you can see there's 70%. There's about approximately, yes, 75% of data, because remember, in the box and whisker plot each interval is broken down into 25%, 25%, 25%, and 25%. Anyways, let's continue. Determine whether the minimum result obtained using A1 is an outlier or not. So we want to check if the value of 15 is an outlier. So remember, there's formula for lower fence and upper fence. So what's given here is a lower fence. Lower fence formula is Q1 minus 1.5 IQR, right? And upper fence formula is, so within the lower fence and the upper fence, if the values are within, then there's no outliers. If it's outside the lower fence and outside the upper fence, there are outliers. Q3 plus 1.5 IQR. So the answer that we're looking for is the lower fence. Q1, what was Q1? Q1 was that's 40, right? Q1 is 40, and we're minusing 1.5 IQR. IQR was 30, right? So this is going to 1.5 times 30 is going to give me 45. 40 minus 45 is negative 5. So you're going to say, since A is the minimum, since A is equal to minimum value, which is equal to 15, is greater than negative 5, it is not an outlier. Okay, so I hope you guys understood that. Nice question, right? And remember, if all your data values are fenced in lower fence and upper fence, then you're not going to have an outlier. You'll get outliers if it lies outside. I hope you guys are understanding. Let's move on to the next question. The table illustrates the approximate time spent in minutes by 7 learners studying for a mathematics test. So there are 7 learners studying for a mathematics test, and their marks obtained as a percentage. So the amount of time spent determines the marks obtained. Predict using the equation of the least squares regression line. What's the least squares regression line? Line of best fit, which is given by y equals a plus bx. What mark a learner who studies for 180 minutes will obtain? So first we need y equals a plus bx. Right, so remember to just put these values into the calculator. Let me pop my calculator so you can see my calculator is here. So go to mode, stat, which is option number 3, and select option number 2. You can see the frequency is on, so press shift mode, scroll down, go to stat, and switch the frequency off, which is option number 2. So we're going to enter all the x values: 0, 90, 90, 80, 90, 120, and 150. Right, and now enter all the y values. 15 equals, then move on to the next one. 59, then 60, 73, 85, 90, and 95. I hope you guys are understanding. Put your calculator on. The data is stored into the stats mode. Press shift 1, go to stat, go to regression, which is option number 5, and select number 1. When I select 1, I'm getting 19,259 plus. Why plus? Because all these values are increasing. As you study more, you obtain a higher mark. So to solve this, value of b, we're going to get, that's the reason why I wrote down positive, because I can see like a positive slope. Go shift 1 and go to regress, option number 5, and select option number 2. We're getting an answer of 0.552. 0.552. 0.552 x. Right, now to obtain a mark, if a learner studies for 180 minutes, what mark will he obtain? So 19,259 plus 0,552 times x, which is 180. Studies for 180 minutes. So we're going to write down, remember mark is a percentage, so you should obtain a mark. And so what we're going to do, 19.259 plus 0.552 times 180. I'm getting an answer of 118.619. 118.619. But you can't get 118, so let's just write that down. 118,619%. So we can't get 118,619%, therefore learner will basically obtain 100%. Learner will obtain 100%. Okay, is this prediction in C1 a reliable one? You can clearly see it's unreliable, because if a learner studies for 180 minutes, he will always get a mark of 100%. So we can say it's not reliable. Not reliable. Not reliable because data suggests that, because the data, why is it unreliable? Because the data suggests that if a learner studies for 180 minutes, he will always get, 100%. So that's the reason why it is unreliable. I hope you guys are understanding. Let's move on to the next question. Okay, this question is on analytical geometry. So what we have, ABCD is a trapezium with AB parallel to BC. We can see AD is parallel to BC. BCD is 90. Because this angle is 90, remember angle D is also 90. So let me just write it there. Let me just draw it there. What's the reason why it is 90? It is 90 because co-interior angles, okay? Lines between the angles between the co-interior angles, 180, the sum of angles. Points A, B, and C are given. E is a point on AC, so that E, so E is a midpoint, right? So determine the gradient of BC. To find the gradient of BC, you know the formula, which is y2 minus y1. So when I say gradient of BC, so let's write down y2 minus y1 over x2 minus x1. So what's y2 minus y1? BC, I'm taking C as the endpoint. 7 BC, 7 minus 4 divided by 6 minus 0. So I'm getting 3 out of 6, which is half. So if the gradient is half here, right, it's also going to be half here, right? And because this is perpendicular, this gradient is going to be -2. So that's the analysis that we have so far. Let's move on to the next question. Determine the equation of the line CD. To find the equation of the line CD, look at that. We already have the gradient. To find the equation of the line CD, right, so to find the equation of the line CD, see what we have. We have the gradient already, so we're going to say gradient of CD is equal to -2. Why? Because BC is perpendicular to CD. Okay, we're finding the equation of the line CD, and we're going to say y minus y1 equals m into x minus x1 at, remember, if the lines are perpendicular, that the gradients are, you know, the product of the gradients must be -1. So half times -2 is -1. Also, to find the gradient of the other line, you can just say negative reciprocal. Reciprocal means the flip. Half becomes 2 over 1, 3/4 becomes 4 over 3, and so on. So at C, we are saying at C, which is 6 and 7. So remember, that's x1, y1. So -7 equals m, which is -2, x minus x1, which is 6. So we got y equals, remember, -2x. -2 times -6 is +12, and then minus the 7. So we got, should be -7? No, add 7. So the final answer is -2x. Therefore we have y equals -2x plus 19. I hope you guys are understanding. Let's move on to the next question. Alright, so I will take the same diagram and copy. Move on to the next one. Determine the equation of AD. Right, we want to find the equation of AD now. To find the equation of AD, we can use point A and the gradient of half. So you're going to say gradient of AD, start with the gradient. Gradient of AD is equal to half, because AD is parallel to BC. Now y minus y1 equals m into x minus x1 at 4, 1, right, at 4 and 1. Why? Because that point lies on AD, and we're finding the equation of AD. So y minus 1 equals m is half into x minus 4, because that's x1, y1. Now open up the brackets here. We got half x minus 2, and take the -1 over, so you get +1, which is y. Therefore y is equal to half x minus 1. I hope you guys understood that. Let's move on to the next question. Let's take the same diagram. Okay, no need to take that diagram. You can just, because the diagram is here. So it is further given that point F is a point in the first quadrant, right? And the coordinates of D is 8 and 3. Coordinates of D is 8 and 3. But remember, we've got the equation of line CD, equation of line AD. We could have found the coordinates of D by points of intersection of these two lines. But anyways, they already gave us 8 and 3. So that's fine. That might be helpful. Alright. Also given now. Now determine the coordinates of F. Easy. We're going to use the slide method. First find the coordinates of E, which is the midpoint. So the coordinates of E is x1 plus x2 divided by 2. So the coordinates of E is 6 plus 4 divided by 2. Midpoint formula, right? And 7 plus 1 divided by 2. Right, so now the coordinates of E is 5, 5 and 4. Now the coordinates of E is 5 and 4, but now we're going to use a slide method. How did we get from 8, 3 to 5, 4? Alright, so we got from D, which is 8 and 3, to E, which is 5 and 4. So how do we go from D to E? Now this method of translation only works for parallelograms, because this is a parallelogram. It only works for parallelogram. Okay, so this line is parallel to that line. Now let's see, how do we go from D to E? So we're going to minus 3 from the X, right? From 8 to 3 there's a minus 3 in the X, right? And from 3 to 4 there's a rise of 1. So this is translation, right? So how are you going to go from 4 1 to F? From A, which is 4 1, we're going to go to F by using the coordinates of 4, which is 4 minus 3, right? And 1, and we're going to add 1 plus 1. It only works for parallelograms. Okay, there is other method where you find the common midpoint, and then okay, you can find the common midpoint between EA, and then because you have diagonals bisect each other in a parallelogram, and you have the endpoint which is 8 and 3, you can get the coordinate of F like that as well. So we have the coordinates of F, which is 1 and 2. I hope you guys understood that. Right, moving on to the next question. Determine EAD correct one decimal place. Let's see EAD. Let's copy this diagram. Okay. Right, so let's find EAD. Right, so I want to find EAD, so which is basically this angle here, angle A1. I don't know what that is, but what we can see is that these two lines are meeting up here, EA and AD. Right, we have the gradient of AD, right, which is equal to half. Okay, so we're going to say a big angle minus small angle. That's the method I'm using. So we're going to say tan alpha is equal to half. So alpha is now equal to, I'm going to use my calculator to solve that. So shift tan 0.5 or half, right? I'm getting 26,565. Right, so I kind of have like a small angle here. Why? Because this angle of inclination on this x-axis makes a small angle, and then the angle of inclination of this one here, maybe it might make oh no, this was the angle of inclination of AD, sorry, and now we're finding the angle of inclination of EA. So what's the gradient of EA or CA? So the gradient of CA is 7 minus 1 divided by 6 minus 4. So that's going to give me 6 divided by 2, which is 3. So now I can say tan beta is equal to 3. This implies beta angle is now equal to tan inverse, I've already got that, tan inverse 3, and tan inverse 3 is going to give me 71,565. Right, so now I can subtract these two angles of inclination. Therefore EAD is equal to big angle is 71,565, right, and minus 26,565. So what we see here is that we're getting 45 degrees. Check. So if you take 71,565, remember I just minus the 565 minus 26.565, so I've got 45 degrees as my angle. Right, so I hope you guys are understanding. I just want to go back and check how many decimal places we are rounding off to. Correct to one decimal place. Alright, so what does the main instruction say? The main instruction says round off to one decimal place unless otherwise stated. Okay, now moving on to the next question. Let me take this diagram, I need it. Right, hence or otherwise calculate the area of the parallelogram ADEF. Right, is there another method to solve this angle here? Yes, you can solve it using another method. You can say calculate the distance AD, calculate the distance EA. No, remember angle D is 90 because of co-interior angles, and then to calculate this angle A here, you can say opposite over adjacent. Obviously you need the distance CD and you need the distance AD, so opposite over adjacent will give you the answer. So tan of EAD is equal to opposite, which is CD over AD. So you need to calculate the distance. That was another method to solve that problem. Now moving on to this problem here. Hence or otherwise determine the area of the parallelogram ADEF. We know this angle EAD, we know this angle is 45 degrees. Okay, so and we know that these two triangles are congruent, 1 and 2. Right, how many marks is this? We need to check. It's 5 marks. So let me say triangle. Why is this triangle congruent? Because see, opposite sides are equal, we have a common line, and see, AF is equal to ED. It's a parallelogram. Okay, that's the reason why. So we can say AEF, triangle AEF is congruent to triangle AED. Right, why? Because opposite sides are equal, right, and you have a common line, so we have side, side, side. Okay, and we have AE as a common line, so we know that they are equal. So let's calculate the distance EA and the distance AD, right, and then use the area rule, half AB sine C formula. Right, so we're going to calculate the distance of EA. So EA using the distance formula is equal to, what was the coordinate of E? The coordinate of E was, remember it was a midpoint, so that's 5 and 4. So EA, I'm going to say 5 minus 4 squared plus, remember x2 minus x1 squared plus y2 minus y1 squared, and then 4 minus 1 squared. Right, so if I work this out, I'm getting 5 minus 4 and 4 minus 1, so that's 9 plus 1, root 10. Right, and then if I calculate the distance AD, right, so the distance AD is going to give me 8 minus 4 squared plus 3 minus 1 squared. Right, and that's going to give me 8 minus 4, that's 16 plus 4, 20. Square root of 20 is 2 root 5, because that's 5 times 4 is 20 if you take the 2 back inside. Right, so now area of palm ADEF is now equal to 2 times half AE, which is root 10, times 2 root 5, which is AD, sine 45. Now let's see how to solve this problem. 2 times half can cancel out, right? We have root 10 times 2 root 5 times sine 45. If you use a calculator, you'll get root 2 over 2, right? Cancel out the 2's, right? And then I've got square root of all this. If you use your algebra, basic algebra, 2 times 5 is 10, 10 times 10 is 100, so square root of 100 is 10 units squared. I hope you guys understood that. Moving on to the next question. Question 3. The frequency polygon represents the results obtained by 27 learners in a mathematics test. 27 learners in a mathematics test. The class intervals are given as, these are the class intervals, right? These are the class intervals. So if those are the class intervals and that's a frequency polygon, I want to figure out what's the frequencies on each one. What were the frequencies? I want to know what's the frequencies. Yes, I want to, let's put the frequencies here, right? And I want to know what's the midpoints. Midpoints. Because maybe we need to find the mean. So what's the midpoints here? 0 plus 20 divided by 2, that's 10. 30, because 20 plus 40 divided by 2. 50, those are the midpoints. 70 and 90. Now, but what are the frequencies? Now, to calculate the frequency, remember this is a frequency polygon. Now, how do you calculate a frequency polygon? You calculate it from a histogram and taking the midpoint of the bars. Right, that was my, okay, my next, okay, so that was my first histogram there. Next one was here. Alright, and the next one was here, histogram, and the next one was here, and the last one was there. Right, so let me draw this histogram. I hope you guys are understanding. So we can get the frequencies. Alright, so I'm just going to take the blocks. Yeah, let me take my rectangles from here. So my first histogram was here, right? Then my next histogram is here. Right, just copying these 5 blocks and it's gonna stretch it here. Right, so my next histogram was right here. Okay, and my next histogram was right here next to that. Right, so I hope you guys are understanding what we're doing here. Remember, a histogram has to be, you know, joint. And the next one was right here next to that. And the last histogram was right here next to that. Now what's the purpose of drawing the histogram? So we can figure out the frequency. So what's the frequency between 0 and 20? The frequency between 0 and 20 is 1. So there was 1 here. The frequency between 20 and 40 is 7. And then between 40 and 60 is 10. And then between 60 and 80 is 5. And then between 80 and 100 it was 4. So I hope you guys understood that. Okay, so we got the midpoints. Alright, this is the midpoints. Right, and we got the frequencies. All we need to work out is the cumulative frequency. Now let's check if this is 18. So 1 plus 7 is 8, plus 10 is 18, plus 9 is 27. So yes, so we have 27 learners. So perfect. Determine the estimated mean of this data set. So how are we going to find the estimated mean? We're going to get the estimated mean from taking the midpoints times the frequency. Lucky we worked that out, right? We extracted the data from the midpoints times frequencies. Okay, so let me put it here. So that's the data values we are working with. So basically what we need to do is we need to take you know, we need to take 1 times 10, 10 times 1, x times f, right? 10 times 1, 30 times 7, 50 times 10, 70 times 5, 90 times 4, and divided by the total number. Right, so the estimated mean is sigma xf divided by n. Right, so what is sigma xf? The product of all the midpoints times the frequencies. So 10 times 1 So 10 times 1 plus 30 times 7 plus 50 times 10 plus 70 times 5 plus 90 times 4, right, and divided by 27. Divided by 27, and I'm getting an answer of, let's work it out. I'm just going to use a calculator here. Alright, so I'm going to enter x and f. No, let's work this out. So that's 10 plus 30 times 7 to 210 plus 50 times 10 500 plus 70 times 5, which is 350. 9 times 4 is 36, so 360. Alright, we're getting 1430 and divided by 27. So 1430 divided by 27, and I'm getting an answer of, divided by 27, and I've got an answer of 52,9. 52,96. How many decimals do they want though? 52,96. 52,96 is my answer. 52,963. So the answer is equal to, approximately equal to, because they want one decimal, it's going to round off to the next one, so 53. Right, so I hope you guys are understanding. So the estimated mean is approximately 53. If it's 53, then it should be in percentage, right? So estimated mean should be approximately 53. Okay, I'll just leave the answer as 53. Let's put it into the calculator and check if we get the same answer, right? So we're going to put frequency and midpoint. So mode, stat, option number 1. I can see the frequency is off, so press shift mode, scroll down, go to stat, and put the frequency on. Alright, so I'm going to enter all the x values. Is 1. No, x values are not 1. The first x value was 10, alright? Mode 1. Let's redo it. Mode stat 1. Right, so the first x values is 10, 30, 50, 70 and 90, and the frequency values are 1, 7, 10, 5 and 4. Put your calculator on, go to shift 1, go to var option number 4 and press option number 2 for the mean, and I'm getting 52,962 or whatever, 963, 52,963, which is approximately 53. What percentage of learners obtain a result in the interval 60 to 80? 60 to 80, what percentage? Between 60 and 80, there were 5 learners, alright? So 5 out of 27, 5 out of 27. So 5 out of 27 times 100%, right? So 5 out of 27, let's see, 5 divided by 27, right, times 100 is equal to 18,5%. So just write 18,5%. So 18.5% of learners obtained a result in the interval 60 to 80. Moving on to the next question. Use the information given on the frequency polygon to draw the cumulative frequency curve that represents the results of this group of learners. Now remember, I need this information here, right? So because we want the cumulative frequency, what do we use? We use the upper class boundaries and the cumulative frequency. So where's the cumulative frequency? So I'm going to draw another row here and put cumulative frequency, right? Cumulative frequency, that's 1. 1 plus 7 is 8. 8 plus 10 is 18. 18 plus 5 is 23. And you get 27 last. 4 plus 23 is 27. Right, so we got the cumulative frequency as well. And remember what to take the upper class boundary and the cumulative frequencies. So these are your points, right? 60, 18, 80 and 23, 100 and 27. Now let's plot these 5 points, right? So we got 20 and 1. Right, so now my data, see how this is going, 1, 2, 3, 4, 5, and this bottom is going in intervals of 2's. Right, so I want the first point to be 20 and 1. Where's 20 and 1? 20 and 1 is right here. Let me draw it in red. That's exactly there. 20 and 1. 0 0 is just going to be 0 0, first dot, because the cumulative frequency before 1 is just 0. Next one, 40 and 8. 40 and 8. 8 is just before this. 40 and 8. Right. Next one is 60 and 18. So I've got 60 and 18. Then is 80 and 23. I think I messed up this one. 60 and 18. 60 and, supposed to be 60 and 18. That dot is incorrect. 60 and 18 is just below this line. Right, so, and it was 80 and 23 right there, and it's 127. Right, so I hope you guys understood that. Now let's draw our graph. Right, so this one is like so close, right, and then going up to 30, right, and then is going up to that point, and then drawing from there to there, and the last point from there to 27, right, 127. Okay, so that was my last point, and now this is what, use the information given on the frequency polygon to draw the cumulative frequency curve. So remember, on this side is the cumulative frequency. Write it down, cumulative frequency, and this is the marks obtained. Right, that's the marks on the x-axis. I think that's what it was. Class interval results, or just write class intervals. Marks or class intervals, right, and just write results. Right, so what we have the results in percentages. Okay, now let's and don't forget to label the curve. This is the cumulative frequency curve, so this is the ogive curve. Now let's solve the next problem. Indicate on the horizontal axis of your cumulative frequency curve in C where you would read off the median. First we need the median position. Median position is half into n plus 1. So it's half into, what's n? N is 27. So half into 28 is the 14th position, which is the median. Now the 14th position matches up here. Let me just use a rectangle to draw this, right? So 14, I need to go to 14 on the y, right, and show you how to use this. Obviously going to use a ruler, right? So I've got 14 there, okay, so it's matching up with the 52, right? 14 and 52, that's what I'm getting. So this is obviously going to take all this out, right? You know what, let's just use straight lines. I'm going to redo that. Take a thinner line. Let's take a thinner line, right? And we go to 14. Much better, okay? We go to 14 and we're going down from here. Right, so I can see I'm getting 14 and 52, right? So this is my median, right? I represented my median. Then, so what's the median? Median is equal to 52. Why 52? Because this is in intervals of 2. Next one, the values to determine IQR. So we're going to say IQR is equal to Q3 minus Q1. Now we need to find the Q3 position, Right, so Q3 position is 3/4 into 28 into n plus 1. 3/4 into 28, 28 divided by 4 is 7, 7 times 3 is 21st, right? And Q1 position is quarter into 28. Quarter into 28 is 7th position, right? So 21 and 7th. We need to go to 21 and 7 as well. Let's go to 7 first and then 21. 7 is right here. Let's take that out. This is a green line. Right, so I've got 7 right here. Right, and now that's representing, which is 38. Right, that's Q1. Now let's move on to the next one, which is 21, alright? So 21 is right here. So let's draw a line from there to there. So let's take this excess part out and come down from here. So I can see I'm getting a line which is like approximately 72, right? So 72 is my Q3. So 72 minus 38. So I'm going to say 72 minus 38. So what is 72 minus 38? 72 minus 38, and I'm getting 34 as my IQR. Okay, so we indicated all the points: Q1, Q2, Q3. Q2 is the median. Is that right? That's 34. It depends on how you draw the curve. Okay, so sometimes you can deviate by 1 or 2. Anyways, using your answer to A and D, describe the skewness of the data. Now when you're doing skewness of data, use the answer to A and D1. D1 is the median, so we're comparing the mean and the median. I think in A we worked out the mean. Now the mean is 53 and the median is 52. Wow, it's so close. So mean greater than the median, right, implies skewed to the right, right? So it's positively skewed. So since it's positively skewed, we're going to say, what's the mean? The mean is 53. The mean was 53. Okay, 53 is greater than 52. This implies data is skewed to the right, or it is positively skewed. Okay, the data is skewed to the right. You can have it, depending on how you work it out, you can have it is symmetrical. You can say mean is equal to the median. It is symmetrical data as well. Okay, so both answers will be correct in this case. Moving on to the next question, which is question number 4. In question 4, we can see the points A, B, and C all lie on the circle with center O. Points A, B, C, since they lie on circle center O, line OA is parallel to BC. Because it's parallel lines, we can take 25 degrees here. Right, because circle center O, that's radii, so this is also 25 degrees. And then because it's circle center O, check angular center equals twice angular circumference. Yes, I can see that. Angular center, and I'm using this chord, it's twice angular circumference. So we know angle O2 is equal to 50. So we got most of the information here, right? Moving on, determine the size of COA. COA, that's easy to find. First we're going to say radii, so OC equals OA, that's radii. Then we can say angle C1 is equal to 25 degrees, because we have, remember, angle C1 is equal to angle C2. Just let me just make the relationship, is equal to 25 degrees. because base angles of isosceles triangle, you need to say angles opposite equal sides, right? And then we know angle COA is 180 minus 50. So COA is 180 minus 50 degrees, sum of interior angles of triangle COA, right? So that's equal to 130 degrees. I hope you guys understood that. Next question, we want to find the size of angle O1. So remember we can find O2, right? And then take 130 minus O2. What's angle O2? That is 50, because angle center equals twice angle circumference using chord AB. So angle O2 is equal to 50 degrees. Angle at center equals 2 times angle at circumference, right? And then we can say angle O1 is now equal to 130 minus 50, which is 80 degrees. I hope you guys understood that. Now let's move on to the next question. Question 5. Use the diagram below to prove the theorem that states that a line drawn parallel to one side of a triangle divides the other two sides proportionally. So there's a line here, right? So it's basically a proof from bookwork, right? So what we do is we need to construct lines BE, right? So we need to construct the line BE. Make sure to draw the construction lines BE and DC so as to divide it into triangles. So I've constructed the line BE, and now the next line is DC. Right? So I've constructed the line DC, almost there. Right, so I've got my construction lines. So what we're going to say is first construct lines, BE and DC. Now we start the proof. We say area of triangle ADE. Now remember, this is the height of the triangle. FE is the height of which triangle? ADE and BDE divided by the area of triangle BDE. So we got half. What's the base of AD? E is AD, and the height I'm using is EF, divided by half. BDE, base is BD, and it's going to have the same height because this is like an obtuse angle triangle, so the height will be on the outside, so EF is also the height, right? And we can see that this is equal to AD over BD. That's what we want, right? And the second one is taking the area of triangle ADE over the area of triangle we're taking the height GD now, or DG, so we need to say ECD, okay? which is half. The base is AE. Why is the base AE? There's a base of this triangle ADE. I'm taking this DG as the height, and it's going to be DG the height of this as well, the triangle ECD. Right, so AE times DG over half EC. See the base of the bottom triangle, ECD. ECD is EC times DG is the height of the second triangle here, right? Which is also the height DG. So we can see, remember to cancel these out, those cancels out, right? So those are the cancellations. So AE over EC. Right, so that's what you have. But now we know that area of triangle BDE is now equal to area of triangle ECD. And what's the reason for that? The reason for that is because same base between the same, see, we have the same base here. So this is the first and this is second. The areas are the same here. Same base between the parallel lines. We can write that down. Has same base between the parallel lines. Right, so this implies, hence the result, this implies AD over BD equals AE over EC. AD over BD, so it's straight bookwork proof, right? AD over BD is equal to AE over EC. I hope you guys understand. Don't forget to leave comments in the comment section below if you don't understand this proof. Right, so we're looking at the next diagram. In the diagram, HIJ is a right angle triangle. So we have HIJ, which is a right angle triangle, right? And L lies on IJ such that JL is 9. Okay, and LI is 12 units. K lies on HI with KL parallel to HJ. HJ is 29. So all the information is given. Determine the length of IK, and it's for 5 marks. Remember, to find the length of IK, first we're going to say we want to find IK. So we can say IK over IH. Now remember, this is a each units were given. So remember, this is also a right angle triangle. Now very important, because they told us it's a right angled triangle, we can use Pythagoras to find HI. So let's find HI. So remember, HI is equal to, by Pythagoras we got 29 squared minus 12 squared. And this is from Pythagoras, right? And 29 squared minus 12 squared, let's pop the calculator. Right, so what do we have? Square root of 29 mode 1, come out from that mode, 29 squared minus, not 12, 12 plus 9 is 21, should be the entire distance. Why did I say 12? Should be 21. 12 plus 9, right? Minus 21 squared, which is equal to 20. Right, so now we know HI is 20. Now you see we got parallel lines here, so what we can say is now HI over KI. Right, so this implies HI over KI is now equal to HI over KI is equal to JI over LI, right? And this is because of prop theorem. And why it is prop theorem? Because the two lines are parallel. You must write parallel lines. KL is parallel to HJ. Right, so we have the answer. Now we have all the quantities. We can just solve for KI. Right, so HI is 20. 20 over KI is equal to JI is 21 and LI is 12. So we can cross multiply and solve. So 12 times 20 divided by 21. Alright, so KI is equal to 12 times 20 divided by 21, and we can get the answer. See, 20 times 12, right, and divided by 21, so we got 80 over 7. Right, so I hope you guys understood that. So it's 80 over 7 units, which is approximately equal to, let's write down the decimal value as well, which is equal to 11,4, because they want one decimal places, right? 11,4 units. Nice, and that's my answer. I hope you guys understood that. Moving on to the next question. We have sine 2x and we have g of x, which is cos x plus 45. With the graphs of f and g on the same, sketch the graphs of f and g on the same system of axes below. Label all intercepts with the axes, turning points and endpoints. So we got 2x, and from minus 90 to 180 they even gave us the intervals of 45, right? So I'm just going to use a calculator and put both the function in. So go to mode, go to table. F of x is sine 2x, so let's put sine 2 alpha x, close the bracket. Put g of x as cos alpha x plus 45, right? And start at minus 90, enter the values, end at 180 degrees, right? And step 45 degree steps. And there we have all the answers. At minus 90, f of x is 0. At minus 90, f of x is 0, then minus 1, then 0. 0, minus 1, 0. I'm just looking at the graph of f. 0, minus 1, and 0. Then I have 1, 0, minus 1, 0. 1, 0, minus 1, and 0. Right, so we can sketch this graph f of x. Which is a sine 2x graph, okay? Sine 2x graph, right? Okay, just make sure that is you get some nice points here, right? So sine 2x graph. Right, so I've got the sine 2x graph here. Label all intercepts with the axes, turning points and endpoints. So we got everything here, right? And this is a graph of f. Now let's look at the graph of g. When it is 0, the value is 1. No, at minus 45. Let's go back. The first value is when the value is minus 90, it is 0, 0,70. So 0, 0,7071. Somewhere around here, right? when the value is minus 45, we're getting 1, and then 0,701, and then symmetrical again is 0,7, right? They want one decimal place. And then at 45 I've got 0, then 0, negative 0,70, and then negative 1, so kind of symmetrical, right? So 0, then I'm getting negative 0,7, and then negative 1, and then at 180 I'm getting negative 0,70, right? So I need to join all these dots. So this graph is going right, turning point is right there, 0,5, 0,7, right? So it's turning there. Yeah, that doesn't even look like it's turning, right? So I just take this point a bit down. Yeah, we should take this point a bit down, it's too far up. Yeah, that looks much better. Right, coming through that, going to 45 and coming down towards there, then through negative 1, and then touching there. Right, so we have a graph which is the graph of G. Right, so we've got both the graphs. We labeled it as F and G. Let's take this F out from here, put the graph of F higher up. Right, so we got the graph of F and we got the graph of G. We can see the points of intersection is somewhere around here, and we definitely know there is a point of intersection here at 135 degrees. That's what we can determine so far from the graph. Alright, moving on to the next question. Determine the values of x for which f of x is equal to g of x. Show all calculations. So that's 5 marks from minus 90 to 180. F of x equals to g of x. Sine 2x equals cos of x plus 45. Remember, sine 2x equals cos of x plus 45 degrees. Right, so there's two ways to we're going to solve this problem using co-ratios. So way is sine positive, right? So sine is positive in the first and second quadrant, so we're going to change the cos into sine. So sine 2x is equal to sine quadrant 1 solution 90 minus the angle, which is x plus 45, because I'm using, you can see sine of 90 minus the angle is cos of the angle. This is quadrant 1 solution. Okay, so I can drop the sign on both sides and make a general solution out of it. So I can say 2x is now equal to 90 minus x minus 45 plus k360, where k is an element of integers. Now we can say 2x is now not 2x, 3x. So we can say 3x is now equal to what's 90 minus 45? That's 45 plus k360. Yes. Now we're going to divide everything by 3. So 15 degrees plus k 120. And quadrant 2 solution, right? Quadrant 2 solution is, well, we can just get the solutions from here. We don't even need quadrant 2 solution. But let's just try to do it and see what we get. We're going to say we have sine 2x, which is equal to sine of 90 plus x plus 45, sine of the angle. Okay, so we got 2x equals, drop the sign on both sides, 90 plus 45 is 135 plus k360 So x is now equal to 135 divided by 2 mod 1, 135 divided by 2. I'm getting 135 divided by 2, 67.5 plus, is it divided by 2? No, no divided by 2. It just basically we drop the sign. I forgot to add the x. We need to add the x here as well. Alright, don't forget that. So there's a x, they take the x over, you get 2x minus x, which is x. So the answer is just 135 degrees plus K360. Alright, so we want to check where's the points of intersection. According to this, they say there is a point of intersection at 135. Yeah, we can see there's 135 points of intersection, and there's another point of intersection which is between 0 and 45, which is at 15 degrees if you make K0 and K0 here. So what's the answers for x? X is equal to 15 degrees or 135 degrees. I hope you understood that. Right, so that's how you solve using co-ratios. Next one, use a graph to determine the values of x for which f of x is greater than g of x. Where's the f graph above the g graph? So obviously you need to add the 15 and the 135, so we know. So this is 15 and that's 135. So where's the graph of f above the graph of g? We can see this is g above f, so from 15 degrees to 135 degrees to 180. So we can say from 15 to 180 including, because they want including as well. So from 15 degrees all the way it is above, right? So from 15 degrees to 180 degrees, the graph of f. So x is an element from 15 degrees to 180 degrees, or you can write it like this, x is greater than or equal to 15 but less than or equal to 180 degrees. I hope you understood that. Just one mark. Where's the product of the two function less than 0? So we're looking for positive positive or negative negative, whether one graph is above, one graph is below, or one graph is below and above and below. So if we're looking at above and below, see the graph is above from minus 90 to 0. So from minus 90 to 0, the graph of g is above and the graph of f is below the x-axis, below the x-axis. So from minus 90 to 0, not including 90, not including 0. So one answer is from minus 90 to 0. Or we're looking for another answer with one above and one below. Remember why we're looking for above and below? Because positive times negative is less than 0. So above and below. Above and below, from look at 45, from 45 degrees to 90 degrees. From 45 to 90, this green graph is below, but the f graph is above. So from 45 to 90. Next solution is from 45 to 90. So we should get from 45 to 90 or 45 degrees to 90 degrees. Right, and I think these two should be my answer. Alright, so I hope you understood that. Moving on to the next question. In the diagram below, ABD is a semicircle with center O. Nice question. BC is a tangent to the semicircle at B. Now because it's a semicircle, make sure you draw this, right? Draw this line, very important. Construct line BD. Why we construct that line? So that we get angles in a semicircle. So we can say D1 and D2 are 90 degrees. Okay, that's a right angle triangle. Right, so that's a right angle triangle because angles in a semicircle, that's the reason why D2 is 90 and then D1 will also be 90. And then we can make B1 and B2. Alright, now because BC is a tangent, we got tan chord theorem. See, we got a circle here, so tan chord theorem. So angle B1 will be, we can find angle B1, right, which is 38 degrees. Now let's see, determine the length of CD correct to one decimal place. We want to find the length of CD, right? In order to find the length of CD, we can get the length of BD. So we're going to say construct line BD. This implies angle D2 is 90 degrees. Reason, angles in a semicircle. Then we can say, we can use the the angle and the radius. Remember that is 7, so radius is also here 7, right? So we're going to say AO equals BO, that's radii. This implies that AB is equal to 14, right? 14 units. Since AB is 14 units, we can use trigonometry to solve BD. So now what we have, BD, yeah, how can we find BD? It's going to be opposite, and this is the hypotenuse, so opposite over hypotenuse. So sine 38 is equal to opposite, which is BD, over the hypotenuse, which is 14. This implies BD is now equal to 14 sine 38, 14 sine 38, and we're getting an answer of 8,619. Right, so 8,619, right, units, that's BD. And remember, angle B1 is now equal to 38 degrees. Angle B1 is equal to 38 degrees. Tan chord theorem. We also know that angle D1 is 90, angles on straight line. Angle D1 is 90. Angle D1 is equal to 90, angles on straight line. Remember, it's geometry, so you got to explain everything. And then we got that to be 90, we got 38 here, we got BD. So what can we use? We can use opposite adjacent, because that's a hypotenuse. So we can say tan 38 is equal to DC over BD. So tan 38 DC, in other words CD over BD, which is 8,619. This implies CD is now equal to 8,619 times tan 38, cross multiply, times tan 38, and I'm getting an answer of 6,7 units. So I hope you guys understood that, right? There might be other methods to solve. If you do find out, please don't forget to leave comments. Thank you. Right, let's move on to the next one. Question 8. Cos theta is equal to a squared minus b squared over a squared plus b squared. Right, so we have cos theta as a ratio where the value of b is between 0. Okay, we got sine theta as less than 0 as well. I think this is a cos diagram problem. Let's see, where's sine negative, and alright, so sine is negative in the, let's write it down, cos diagram, right? So sine is negative. No, where, now how do we know whether this is positive or negative? So a squared minus b squared, because a is greater than b, this is positive, and the denominator is always positive. So a squared minus b squared has to be a positive answer. So what we know is a squared minus, so where's cos positive? Fourth quadrant and first quadrant. And where's sine negative? Sine is negative in the third and fourth quadrant. So your diagram should be in the fourth quadrant, okay? Because they say sine theta must be less than 0. Now the cos theta, right? So theta should be in the fourth quadrant. That's a reference angle. That's theta outside. Adjacent of a hypotenuse, so this is a squared minus b squared, and the hypotenuse is a squared plus b squared, right? So we need to find y, right? So y is equal to negative, right? Square root of a squared minus b squared all squared. No, a squared plus b squared is the hypotenuse squared minus this. Why is the value of y negative? Because it's in the fourth quadrant. Subtract a squared minus b squared squared. So basically that's what we are doing. This is from Pythagoras. This is from Pythagoras theorem. So y is equal to negative. Let's work out everything within the square root. So that's a to the power 4 plus 2a squared b squared, squaring a binomial, plus b to the power 4. Right? Now remember, we're going to take the negative inside, so minus a to the power 4, and the middle term over here is minus 2a squared b squared, so plus 2a squared b squared, minus and minus. And remember, this term in the bracket is going to be b to the power 4, so minus b to the power 4. Right, so we can see a to the power 4 minus a to the power 4 cancels out, b to the power 4 minus b to the power 4 cancels out. We got y is equal to negative square root of 4 a squared b squared, so which is basically equal to negative 2ab. Right, so that's the value for y, which is negative 2ab. This implies tan theta is now equal to opposite over adjacent, so that's negative 2ab over a squared minus b squared. If you want to cancel out the negatives, then we can say 2ab divided by b squared minus a squared. So I switch this bottom part around with a negative outside, and negative cancels out. Right, so that's my answer, b squared minus a squared. Yeah, so that's your final answer. I hope you guys understood that. Moving on to the next question. It is further given that what's happening? It is further given that a equals 3 and b equals 2. Solve for theta. That's quite simple, because we can just substitute into the original that we had. See? Or we can just use the, if it is further given that a equals 3, b equals 2, solve for theta, so we can just use the tan, right? So we can say tan theta equals, let's use the original one, minus 2 ab, a is 3, b is 2, divided by a squared minus b squared, 3 squared minus b squared, which is 2 squared, right? So we got, let's work this out, fraction, put a negative, 2 times 3 times 2 divided by 9 minus 4, right? So that's minus 12 over 5. So we know for tan general solution just 1. So a reference angle for tan is tan inverse negative, not negative, 12 over 5. Okay, now because theta was in quadrant, we want to see what the angle for theta can be. Because it was in quadrant 4, tan inverse 12 over 5, right? So we're going to get an answer here. So we're going to say shift tan 12 over 5. We got an answer of 67,4. So where's tan negative? Cast a diagram. So tan is negative in the second quadrant. Just do this, right? Just use the second quadrant and we're going to get a general solution here. We don't use third and fourth quadrant when we use tan, okay? So what we can say is theta is now equal to 180 minus 67,4 plus K180, because the K180 takes into account the third and the fourth quadrants. So 180 minus 67,4, 180 minus 67.4 is going to give me 112.6 plus K180. So now we can write down the values for theta. Therefore, theta is now equal to two answers. Now remember, if I make k equals 0, 112.6 is not in the fourth quadrant. We want the answers in the fourth quadrant. So add the value of k, which is 1. So 180 plus 112.6. So let's try that. 180 plus 112.6. Right, so that's going to give me 292.6. And the second solution will be, remember, you are in the fourth quadrant, right? So now this is 292.6. So now how will you come back to the fourth quadrant? By going another revolution right around. So you kind of like just adding 360 again to 292.6. So plus 360. So this is a thinking problem, right? 0652.6. Right, so those are my two answers. You can't give all the general solution because that does not work. It's going to give you different quadrants. We only want the fourth quadrant answers, okay? We want answers because this is in the fourth quadrant and this is also in the fourth quadrant. Right, so I hope you guys understood that. Moving on to the next problem. Simplify the following expression containing only one trigonometric ratio of theta. Nice question, because this is got to deal with the cast diagram and simplification. So half, what's cos of 90 plus theta? Cos in the second quadrant is negative, right? So it changes to negative sine theta because of the 90, minus sine theta, sine of theta minus 90. So what we're going to do is we're going to add sine of theta minus 90. We can change it to using negative angles. Remember, sine of negative angle is equal to negative sine angle, right? So you need to take out a negative here, so it's going to become negative sine 90 degrees minus theta, right? Or you can add a 360 and make it 270, right? Cos squared 180, we're not going to worry about that because it's squared, so it's just going to become cos squared theta because of the 180. Trig ratios do not change. Cos of negative angle is positive angle, cos theta, plus cos squared, so cos of theta plus 90, that's going to become sine. Alright, so we can just write down sine squared theta, okay, because I kind of squared the negative already. Now on the top, right, so what we have at the bottom is we got cos squared plus sine squared, which is 1. So we got 1 minus 2 cos theta at the bottom. On the top we got negative half sine theta, right? Positive, because negative and negative is positive, sine theta, right? And this is going to give me cos theta, right? So I hope you guys understood that, because sine of 90 minus theta is in the first quadrant, and because of the 90 it changes to cos theta, right? So now we got sine theta, cos theta. Now we need to decide what to do here. What can we do here now, because we got half sine theta there. What we can do is we can take out half sine theta as a common factor. See, let's take out a negative half sine theta out. Yeah, why? Because obviously Sine theta is common here and there, so let's take out a negative half. So we left with 1 here, right? Minus, remember 1 divided by negative half, 1 divided by negative half is 2. So we left with minus 2 cos theta. Perfect. And see, if you multiply it out, minus half times minus 2 is positive sine theta cos theta, so it works out. And then we can cancel out the factors. So what's my final answer? My final answer is negative half sine theta. So I wrote it in terms of a single trigonometric ratio. I hope you guys understood that. Moving over to the next question, proving the identity. Now how can we prove the identity? We have sine theta, tan theta. Now whenever you have something like this, always whenever you have tan in the denominator, try and if you have tan in the denominator, try and write it as a division, write it in a single line. So we have sine theta times, what is tan theta? Tan theta is sine over cos, right? And I'm going to divide it by tan 2 theta into 1 minus sine squared theta over cos squared theta. So I hope you guys understood that. Now sine times sine is sine squared theta over cos theta divided by, look at tan 2 theta, I'm just going to leave it as tan 2 theta. You can write it as sine 2 theta over cos 2 theta. Now we're going to do LCD here. That's 1 over 1, so cos squared theta is my denominator, right? And on the numerator I've got cos squared minus sine squared. Okay, cross multiply. Right, so far we can see that cos squared minus sine squared is cos double angle, right? Right, so divided by sine 2 theta over cos 2 theta, and then that's cos double angle over cos squared theta. Right, so now what we have is these things cancelling out. Now we know what sine double angle is, so we should have changed it here. Sine double angle is 2 sine theta cos theta, 2 sine theta cos theta. So we can cancel out one cos from here and one cos from here. Now we're going to change this division into multiplication, and whatever we have in the denominator goes on the numerator, which is cos theta, and in the denominator we're going to have 2 sine theta. Guess what now? Cos theta cancels out, the sine theta cancels out with one sine there, so we are left with sine theta over 2, which is equal to RHS. So I hope you guys understood that. So it wasn't difficult, it was just a matter of rewriting it. So whenever I have tan in the denominator, I always write it like this, divided by. Don't write it over, because then you'll run out of space. Determine the general solution for the values of theta for which the identity is not valid. When is the identity not valid? Not valid means it's undefined. So when is the identity undefined? When the denominator is 0, when you divide by 0. So tan 2 theta into 1 minus tan square theta is either tan 2 theta is equal to 0 or 1 minus tan squared theta is equal to 0. Right, so what I'm going to do here is I'm going to write tan 2 theta is equal to 0. Let's try with the first one. How many answers do they want there? For the values of theta for which the identity is not valid, write your answer as one single statement. So I think they just want one answer. or no, we have to work it out for both. So tan 2 theta equals 0. So tan 2 theta is equal to 0, or 1 minus tan squared theta is equal to 0. Now tan 2 theta equals 0 gives us, remember this is sine over tan 2 theta is equal to 0, right? So reference angle is just 0, so 2 theta is equal to 0 plus k180, because tan of 0 is 0. Okay, so we take 0 as positive, so theta is equal to k 90 degrees. That's one answer, where k is an element of z. And 1 minus tan squared theta equals 0, so you can say tan squared theta is equal to 1. Now you can't just write it as 1 because we need to have a plus minus, so tan theta is equal to plus or minus 1. Now we have general solution when tan is positive or when tan is negative. So let's see, theta is equal to, when tan is positive, is 45 degrees plus k180, right? Or, so how many answers we got here so far? 1, 2, or when theta is equal to, when is tan negative, in the second quadrant, and the reference angle is 45. Remember, the reference angle is 45 degrees. So 180 minus 45, when is tan negative, in the second quadrant as well. It's positive here and negative there. So 180 minus 45 is 135 degrees plus k180. So I've got 3 answers. So how can I write this answer down now? Write your answer as one single statement. Write your answer as a single statement. K is 90. How can I write my answer as a single statement? Theta is equal to, we can think about whether for tan, we can think about where the asymptotes are for tan 2 theta. For tan 2 theta, the asymptotes are at 90. So at 90, not 90, 45. So you can say theta is equal to 45 degrees. 45 degrees. And when will the next asymptote be? So remember 270. I need to look at answers for theta when it is undefined. So the possible answers for theta is when the value of k is, let's see, theta equals, when it's undefined. Undefined if theta equals, if the value of k is negative 1. If the value of k is negative 1, I'm getting negative 135. Negative 135. If the value of k is, I need to look at all three, alright? All three identities. If the value of k is negative 1, I'm getting 135 from here. If the value of k is negative 1 here, I'm getting negative 45. If the value of k is negative 1 here, I'm getting negative 90. So let's go negative 90, negative 45. Please write them in order. And if the value of k is 0, I'm getting 0, and so on. So we can see this here is stepping up into 45 degree intervals. So it's like a number pattern. So we should write 45 degrees k, where k is an element of integers. So I hope you guys understood that. So now if the value of k is 3, it's going to give me this answer. If the value of k is 2, it's going to give me negative 90, and so on. So I wrote theta as a single statement. I combined all three answers into one. So I hope you guys understood that. Very nice question. Quite difficult, because if you don't write this you might lose a mark, because see what they said. Write it as a one single statement. Right, next one. Looking at question number 10, we have in the diagram ACD lie on the circle center O. Because that's center O, remember angular center equals twice angular circumference. AE and D are tangents to the circle at A and D respectively. So AE and DE are tangents. So remember tangents from common point. So we know that they are equal. We know that this here is also equal. So we have a kite here, right? Okay, so let's continue. So remember this is also 90, right? Because tangents meet chord. Prove that AODE is a cyclic quadrilateral. Prove that AODE is a cyclic quadrilateral. AODE, it is, because now we prove that the opposite angles are supplementary. What is this? This is so simple, man. AODE is a cyclic quadrilateral. So what we're going to say is that OAE is equal to 90 degrees, because radius is perpendicular to tangent. OAE, also ODE is also 90, same reason. Because we have radius perpendicular to tangent. This implies, what does that imply? OAE plus ODE is equal to 180, and adding up those two angles, and now you have opposite angles supplementary. OAE plus ODE is equal to 180 degrees. Therefore AODE is cyclic, and the reason is converse opposite angles of cyclic quad. Right, converse opposite angles of cyclic quad. Determine angle E. How are we going to find angle E? Well, we are given that ACD is 68. ACD is 68 degrees. Simple. Then we can get angular center equals twice angular circumference. We got angle O2, which is 68 times 2. 2 times 68. 2 times 68, we got 136. Angle at center equals 2 times angle at circumference. Okay, and what else we know? So we got that. Then opposite angles of cyclic quad. So angle E is 180 minus O2. Angle E is equal to 180 minus 136. Opposite angles of cyclic quad AODE. Please label the cyclic quad, right? And 180 minus 36, so 180 minus the answer, I've got 44 degrees. So I hope you guys understood that. Moving on to the next question. Which is question number 11. What we have is the equation of the circle with center C is given by x squared plus y squared minus 12x minus 4y plus p is equal to 0. Right, so we have the equation of the circle. AO, OB, AB are tangents to the circle. B is the point 12, 0. Right, so those are all tangents. Okay, what's the first thing? Determine the value of p. Now, how are we going to find the value of p? How are we going to find the value of p? Alright, so what we're going to do here is we're going to work with this equation and complete the square. Let's write it in center radius form. Right, so CR form, which is x squared. Let me just check now what's the equation of the circle. X squared minus 12x plus minus 12 divided by 2 squared plus y squared, because I took the coefficient and I divided by 2 and I'm squaring it, plus y squared minus 4y plus minus 4 divided by 2 all squared is equal to, right, so I got x squared minus 12x, y squared minus 4y. Right, so I used up all those 4. Take the p over, I got negative p. Right, and add these values. This is negative 12 over 2 is, because I added it on the left hand side, I must add it on the right hand side. So I've got minus 6 squared, which is 36. So we kind of adding 36 and we kind of adding a 4 there. So I've got 40 minus p here. Right, so minus p plus 40. And on this side I've got x minus, what's the value of this? Minus 6 squared. And what's the value of this? Y minus 2 all squared. Right, so I hope you understand this. So we know the center is 6 and 2. So we know the center of the circle is 6 and 2. Center is 6 and 2. So what's the height here? That's 2. And what's the center? The distance from there to there is 6. Right, so perfect, problem solved. Remember, this is also 90, right? So the distance from here to there is 6. So center is 6 and 2. So we can say the radius is equal to 2. Now if the radius is 2, remember we have 40 minus, remember this is r squared. So we know r squared is equal to, radius is 2. So, and in this case it was the square root of 40 minus p. Isn't that's what be the radius? So the radius is 2 from the diagram, right? Because the way the diagram is constructed is on the x-axis, so I brought down a line. Now if I square both sides, I've got 40 minus p is equal to 4. Right, solving this third equation, this implies p is equal to 40 minus p is equal to 4. So p is equal to now 40 minus 4, which is 36. So I've got the value of p, which is 36. Right, perfect. Nice question. Next question. Determine the equation of AB. Show all your working. Determine the equation of AB. Show all your working. How many marks is this? 7 marks. So looks like a difficult question here. Let's put it here. Let's put the diagram here. So when we're working on the diagram, we can work with something here. Let's find the equation of AB. But we don't have the coordinates of A. Got a problem here to find the equation of AB. Okay, what we do have is something like this. Look at this. What we have here is this line BC. Right, so let's draw this line. So join, construct line BC. Right, so let's try to find the, let's find the gradient of BC. Should we find the equation of BC? This is 6 and 2. I've got the coordinates 6 and 2. So if we find the gradient of BC, then if you find the gradient of BC, so remember the distance from there to there is 6, and the distance from there, because radius perpendicular to tangent, we know the distance from here to there is also 6. How can we solve this? How can we solve this? what we have here is 6 and 2. Let's find the gradient of BC first, because that's the only two coordinates that's given. The gradient of BC is 2 minus, no, the gradient of BC is already 2 over 6, so negative 2 over 6. That should give you negative 1/3, right? Because that's change in y over change in x. 2 over 6, that's negative 1/3, right? Or you can say 12 minus 6 divided by, no, 2 minus 0. Let's work it out like this, fine. Like y2 minus y1. BC, alright? So what we have is 0 minus 2, 0 minus 2 divided by 12 minus 6. Right? So we got 2 over 6. So we got 1/3. That's right. Let's label this point here as K. So we know CK is perpendicular to OB because we have a radius perpendicular to tangent. Okay. Now where are we going with this? We want to find the equation of this line. Right. Maybe if we find the inclination angle here, maybe we need to find some inclination angle. If I find the inclination angle here, that's not going to be helpful. If we find the inclination angle here, no, let's find the angle. Why should we find the angle on the outside? Let's find this angle over here. Why are we doing this? If we find this angle, because we're trying to get as much information as possible with the angles and the sides, right? We're trying to get as much information as possible. Okay, so what we can do is, remember this angle will be equal to that angle because of properties of a kite. We can draw another perpendicular there. Right, so we can say that this triangle and these two triangles are congruent. Right, because remember this is 6 also, this is a common line, that's 90 and that's 90. So you can call this point D. So let's say because these two triangles, triangle 1 and triangle 2 are congruent, then yeah, these two triangles are congruent, then we can get the gradient on the outside and then we get 12. Alright, so we kind of have something here. So we got to work out this angle. So we can say tan theta, which is, I'm calling that angle, is equal to 2 over 6, opposite of adjacent, which is 1/3. So this implies theta is equal to, let me take this angle out and put theta there. So theta is equal to shift tan inverse 1 over 3. So we got 18,43 as our answer here. Then we can say triangle CKB is congruent to triangle, remember CKB is congruent to triangle CDB, because we have, remember, tangents from common point. BD is equal to 6. Suppose we say these things, right? Let's say CD is perpendicular to CD is perpendicular to AB because the radius is perpendicular to tangent. Okay, and now what we're saying is radius is perpendicular to tangent. These two triangles are congruent because we have 90 here, we got 2, we got 2, so we got 90 degrees hypotenuse and the side. So we got RHS, right, so far. And now what we can say is that, remember, this angle is also theta, so CBD is equal to 18,43 degrees. Reason, congruent triangles from this. So now this entire angle over here is so what's the angle of inclination on the outside? Example ABX, that's the angle of inclination. Let's call that beta. So beta is equal to ABX. So what we can say is tan beta is equal to 180 minus 2 theta. Right, and we know theta is equal to 18,43. So tan beta equals 180 minus 2 times answer, so 143,13, right? So beta is now equal to shift tan, answer I've got 89,59. Wait, something's wrong here. Shift tan 143.13. So I'm getting 89,59. Tan inverse 143,13. Why is such a large answer? I took 180 minus this angle 2 theta to get this here to be, okay, the angle on the inside tan beta if I join this line, okay, I've got twice the angle here. If I join up this line AK, then I can have a height and the distance is 6. Okay, let's try something here. The angle on the outside is beta. Ah man, why am I writing this? This is incorrect, right? So it should be tan beta is equal to gradient. Remember, gradient is equal to tan beta. So tan of 180 minus 2 theta is equal to the gradient. That's what we're trying to find. That's a gradient. So m equals tan of, should be tan of 143,3. 180 minus 2 times 18.43. So I'm getting this answer here, 143,14, which is tan of the answer is going to give me 0,75, 0,75, which is negative 3/4 approximately. Right, so now we have a gradient. We can say y minus y1 equals m into x minus x1 at 12 and 0. So the y value is 0. So y is equal to m is negative 3/4 x minus 12. So y is equal to negative, remember y minus 0. So negative 3/4 x minus 12, and 4 cancels out 3 times, so plus 9. So I hope you guys understood that. I just want to double check my answer if that is correct. Let's go up and see. Right, so we subtracted that. We said those two triangles are congruent. Minus 0.7, what did we have? Yeah, the rounding off to 2 decimal place and negative 0,75, so that should be like more accuracy. Minus 3/4 x minus 9. Okay, I'm gonna stick with this. I don't think we went off anywhere. Right, so moving on to the next question, which is part C, and then go on to question 12. A second circle with center 0, 9 Okay, so I need this information here. Let's go back to the original. A second circle with center 0, 9. 0 and 9 will be somewhere around here, right? With point 2, 3 that lies on the circumference is drawn on the same set of axes. Do the circles intersect? So I need to look at circle C1. Circle C1, the center was, this is C1, alright? The center is 6 and 2, and the radius is, let's just call it the circle center C1. C1 is 6 and 2, radius 1 is 2. Circle center 2, we have center which is 0, 9, so x squared plus y minus 9 all squared is equal to r squared at, because we need to find r here, at the point 2 and 3. So if I substitute the point 2 and 3 inside here, I'm getting 4 plus 3 minus 9 minus 6 squared is equal to r squared. So r is equal to 36. Remember, this is 40. R squared is equal to 40. Therefore r is equal to square root of 40. Right, and this is my second r. Remember, r has to be positive. That's the reason why we're taking that. So if I add the distance, do the circles intersect? We're checking for intersecting circles, right? So we know there's another circle here with r being root 40. There's another circle center here. I don't know whether they intersect or not. So that's another center. So we need to find the distance between the centers, center C1 to C2. So the distance between the centers, let's find the distance between centers is equal to square root of, using the distance formula, the square root of, what's the center here? The center here is 0 and 9. So 6 minus 0 squared plus 2 minus 9 squared, and that's equal to, using our calculator, that's the square root of 36 plus 7 squared is 49. I'm getting square root of 85, which is 9,21. Let's just say 9,2. And the sum of the radius, the distance between the centers, right? The distance between the centers, now we're working out was r1 plus r2, sum of the radius is 2 plus square root of 40, 2 plus the square root of 40. I'm getting an answer as 8,32. Right? I've got 8,32. The distance between the centers is 9,2, right? But the sum of the radius is kind of smaller, so see. So I don't think they're not going to intersect, because this is 9,2, so we're going to say they do not intersect. 9,2. So what we can say is C1 to C2 is clearly greater than R1 plus R2. This implies they do not intersect. So if the distance between the centers is less than the sum of the radius, then they will intersect. If they are equal, then they will touch externally. Right, so I hope you guys understood that. Now moving on to the next question. Question 12. In the diagram, circle with center O has diameter AOC. Right, since that is the diameter, we have a right angle triangle. Alright. And chords AB and BC. AB and BC are chords, alright. Chords AD and EC intersect at F, with OF perpendicular to EC. That's given. It's perpendicular. Since that is perpendicular, we know EF is equal to FC. AOC bisects BCE. AOC bisects BCE. BCE. So C1 and C2 are equal. Alright. So state all relevant reasons with your statement. Prove that triangle ABC is similar to triangle OFC. So we need to write in triangle ABC. Let's do it in the side here. In triangle ABC and triangle OFC. So what information do we have? So ABC and OFC. We know angle B is 90 degrees. That's because angles in a semicircle. Then we know that OFC, angle F1 is equal to angle B. Angle B is now equal to angle F1, right? So that's your first reason. Second one, that's your first one. The second one is, remember what we have. Angle C1 is equal to angle C2 because they are given. Right, that's given. And the third one is just basically sum of angles of triangle, the remaining angles, right? Which is angle A2 is equal to angle O2. Angle A2 is equal to angle O2, and that's sum of angles of triangles, or the third angle. So this implies that triangle ABC is now similar to triangle OFC, and the reason is angle. I hope you guys understood that. Next one, determine the numerical value of BC is to FC. BC to FC, stick this diagram down. Remember, we're solving this question here for 2 marks. BC to FC. We have BC here and we have FC over here. Right, so we can use what we proved above. So we know we have similar triangles. So we're going to choose this. From similar triangles, we know that the sides are in proportion. So I just want to see what we need to take. Remember, we need BC to FC. So BC is to FC. And what else we need? We need BC to FC. Do we have AC? Yeah. We can take AC is to OC. Remember, that's a radius. So let's mark these equal. So we can call it R and R. Right? So we can call it R and R. We got 2R here. Oh, you can say OC is, we can say AC is twice OC. So what we can say here is BC. We need to write that down. That's a radii, okay? AO is equal to OC. Let's write that down. AO is equal to CO, which is equal to R, and that's a radii. Right? Next I'm going to write down AC over AC over BC AC over BC is equal to OC over FC. That's because we have similar triangles and we have sides in proportion. So we want OC to FC. Remember, OC is 2R and FC, OC is R. OC is R, and why we have AC over BC? AC over BC is equal to OC over, no, it's not FC. Why did I choose FC? Supposed to choose one from here and one from here. Okay. AC over BC. Is that right? We chose AC. We want BC to FC. BC to FC. That's what we want. We want BC to FC. Yeah, no, we made a mistake here. So we know AC. AC is basically 2R. So if you take FC up and AC down, you should get the answer. But why are we doing it like that? If you take this FC up and, okay, we need to rewrite this. Let's take it according to BC is to FC, right? So that will work out better. Let's take it like this rather, BC to FC. So we're going to say BC to FC. Right, you can also write it like this. BC to FC is equal to AC to OC. Right? So BC to FC is AC to OC. What is AC? AC is 2R is to OC, which is R. So 2 is to 1. So this implies BC to FC is 2 is to 1. I hope you understand that. Right, let's move on to the next one. 2 is to 1, not R. Nice problem. Let's copy this and put it here. Right, so we want to simplify this, and this is basically 7 marks. So we got to think about what we need to do. Right, so remember that these angles are equal. Angle C1 is x and x. So maybe we need to use this. Let's see, AC squared. So we got AC squared over 2 minus AB squared. Alright, so AC squared and AB squared, we can use Pythagoras here, right? So let's try to simplify this. So if we try to simplify this, left hand side, what we can say is AC squared over 4 minus AB squared over 4. Right, so we got, but we know that AB squared and we have AC squared, right, which is basically equal to, remember, BC squared. So we know BC squared is equal to AC squared minus AB squared. That's from Pythagoras. Right, so what we can do is we can write down this AC squared minus AB squared over 4 is equal to BC squared over 4. BC squared over 4. But now remember, BC to FC is 2 is to 1. But we're trying to simplify, substitute this from part B. But BC to FC is 2:1. BC to FC is 2:1. Then isn't we can replace BC with FC. We can replace BC with FC. So this implies BC cross multiply BC is equal to twice FC. BC is equal to twice FC. Then if I try to replace BC squared over 4, if I square both sides here, I'm getting BC squared is equal to 4FC squared. So BC squared over 4 is basically equal to FC squared. This implies BC squared over 4 is equal to FC squared. Right, so that's what we have. That's part 1. This is part 2. This is from B. Right, from part B. Now that's the information we have. So far we have the left hand side simplified to FC squared. Right? So the left hand side simplifies to FC squared, which is the left hand side. Right. Now we want to check the right hand side. Left hand side is this. What's the right hand side? To get the right hand side, which is DFFA, we're dealing with DF and FA. But see, DF and FA are these lines. It's the line on this, on the other triangle. So we want DF and FA. Right? Looking at those two lines here. So how are we going to get DF and FA? Let's try to use try and use circle geometry, you know, circle proofs here. Maybe we need like another similar triangle for DF times FA. Let's see. So we can say in triangle, remember angle C1 here, so angles in same segment, C1 is equal to D1. So this is X, then this is X, and angle E is F. If that's Y, then angle A1 is Y. So we should say in triangle CFA and triangle CFA and DFA. So next thing, in triangle CFA and triangle DFA, and I want to prove another similarity here because we're working with those lines. CFA and DFA. In triangle CFA, the order, and DFA. Right. So we can say angle C1 is equal to angle D. First one we can say angle C1 is equal to angle D. Angles in same segment. Right. Second one, same thing. Angle E equals angle A1. Angles in same segment. And the third angle will be EFD and CFA. So CFA and CFA and DFE. Why did I write A here? Should be DFE. I'm proving CFA and DFE. Alright, so CFA is equal to DFE, right, and that is sum of angles of triangles, sum of angles of triangles. This implies triangle CFA is now similar to triangle DFE, and that's angle, 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 right? CFA is similar to DFE. CFA is similar to DFE. Now if you want DF and FA, how are we going to get DF and FA? So see, we have DF and FA. So it makes sense. You need to say CF over DF CF over DF equals FA over FE. Now if you cross multiply this, you get DFFA. You're getting DF times FA is now equal to CF times EF. Now the reason for this is similar triangles, sides in proportion, right? Now what we can say is we have DFFA, CF and EF. What's CF and EF? CF is equal to EF. Why? Because line from center perpendicular to chord. F is a midpoint. So CF is equal to EF. But CF is equal to EF. That's line from center perpendicular to chord. So we can replace EF with CF. So we got CF. This implies we got DF times FA, CF times CF, which is equal to CF squared, which is right hand side. So what can we say? Therefore FC squared is now equal to DF times FA. Right, so we got left hand side. We proved that the left hand side is CF squared or FC squared, and we proved that the right hand side is also CF squared. So problem solved. So I hope you guys understood that. Therefore, what was FC squared? This implies the original. You need to write down the original sum. This implies, alright, this implies. So imagine now 7 marks. You got to think. You have to prove a third. You have to go and prove a second. Yeah. So you must write down the last thing, because remember that was FC squared and there's DF times FA, and that's it. That ends the proof. Now the last question, question 13. In the diagram below, a house is in the shape of a prism with a triangular shaped roof with one side CN, which is 10. Okay, so that's the house length. A vertical tree is growing at point T in the garden. NCT is equal to 65 degrees. That's 65, that's 69. The angle of elevation of the top of the tree from C is 43,5. From the top of the tree to C is 43,5. So you have like another triangle here. Right, so looking at that triangle from C to there. Yeah, because it's in 3D, it's a bit hectic. The angle looks bigger, but it's not actually. So I'm going to draw another triangle there later on. Right, because this is a horizontal plane and that's the vertical plane. Remember, in the vertical plane, we have the height of the tree, and we have a 90 degree, alright, to the horizontal, and this is C, this is T, and that's A. So AT will be the height of the tree. Now, is it possible for the tree to hit the house if it falls? Sure. How many marks is that? 8 marks. Wow. Let's see. Now, how do we solve this? So we can see on the horizontal plane we have two angles, so we can calculate this angle T here, NTC, because I want to use the sine rule. I want to use the sine rule and calculate CT. I want to calculate CT here, right? So NTC is equal to 180 minus 69 minus 65, so sum of angles of triangle. So we got 180 minus 69 minus 65, so I've got 46 degrees, right? This is sum of interior angles of triangle NTC on the horizontal plane. So we know this angle is basically 46 degrees, right? Now what we can do is we can use a sine rule and calculate CT. So if I use a sine rule and calculate CT, I'm going to get sine 69 CT over sine 69 equals 10, NC is 10 over sine 46. So this implies CT is now equal to, not CF, CT so this implies CT is now equal to sine 69 times 10 over sine 46. Just take the sine 69 across, so 10 over sine 46 times sine 69, right? So I'm getting an answer of 12,978. 12,978 12,978 meters. I think it was in meters. Yes, 12,978 meters. What if the tree falls in this direction, NT? Let's calculate NT as well. So we're going to say NT over sine 65 remember we still need to calculate the height of the tree, so I'm trying to calculate this height here as well. If the tree falls in that direction or in this direction, I just want to see what's the distance away. So NT over sine 65, should we calculate NT? Let's just calculate it. We're not going to lose marks, so then we realize, then we can figure out which one to use. So what is NT? NT over sine 65 is equal to 10 over sine 46. I can use the sine rule again. So this implies NT is now equal to, so 10 over, we're going to say sine 65, right? NT is now equal to 12,599, 12,6 meters, right? So that's what I have so far. Next thing, we're going to calculate the height of the tree, right? So the height of the tree, we need to use this triangle here. So the height of the tree is, the height of tree is 80, and we have this angle over here. The angle over here is 43 comma something. What it was? 43,5 degrees. This angle is 43,5 degrees, and we know CT is given, right? So we have CT already, which is 12,978, right? So you can use opposite over adjacent, so we can say tan 43,5 is equal to 80, which is the height of the tree, over opposite over adjacent 12, 12,978. This implies AT is equal to 12,978 times tan 43. 12.978 times tan 43.5 degrees. So that's 12,31. 12,3 meters. Alright, so far what we have is we got NT, we got CT, right? So if the tree falls in that direction, it's still going to be less, so it won't hit. If the tree falls in this direction, it won't hit. What if the tree falls straight from here to there? So let's try to calculate this other distance, which is NCT, perpendicular. So what if the tree falls straight off the house? So let's try to calculate another distance. That's where the tree is, okay? And that's NC, right? And we know the angle at N. So I'm just looking at this NCT. NCT. So I want to calculate if the tree falls straight ahead, perpendicularly, right? So we know this angle C is, what is that angle? Let's call this, if the tree falls in this direction, let's call it F, right? So if the tree falls in this direction, where's the tree? The tree is here, right? So it falls straight down like this in this direction. So we know so far it won't hit the house because the height of the tree is 12,3 meters. If it falls in that direction, this direction NT is 12,6, right? And this distance of here TC is almost 13 meters, so it's not gonna hit so far. So now I want to try and calculate this in between height, the perpendicular height there. So angle C here is 65, right? We have CT 12,978, and obviously we can get this perpendicular height here, right? So this is the perpendicular height. Let's just call it F. So what can we use? Opposite and hypotenuse. So we can say sine 65 is equal to F over 12,978. This implies F is now equal to 12.978 times sine 65 times sine 65. That's going to give me 11,76 11,76 meters. So therefore that's 11,76. Whoa, so if the tree falls perpendicular like in this direction, it will hit the house, right? So so it's possible for the tree to hit the house. So is it possible for the tree to hit the house if it falls? So yes, it is possible for the tree to hit the house. It is possible, right? Because we got another possibility here. It is possible for the tree to hit the house. I hope you guys understand. Don't forget to subscribe to my YouTube channel, and I hope you enjoyed this video.